So let's look at one last example of the direct proof technique. So here the proposition is going to be the following. Say A, B, and C are real numbers, and also say that A is greater than B. Then if AC is less than or equal to BC, then C is less than or equal to 0. So we have a bunch of stuff that's given to us, and the actual claim right here, you notice, is an if-then kind of statement. If this inequality, then that inequality. So that makes us think, oh, maybe we can use a direct proof kind of example right here. So let's go ahead and try to prove this. First off, anything that I was given, I just write down verbatim. It was given to me, so I write it down. Now, since I am working with my direct proof technique, what I'm going to do is assume my hypothesis of this P implies Q statement right here is true. So assume that AC is less than or equal to BC. That's how all direct proof examples are going to start out with. You assume that your hypothesis here is true. So what we want to somehow do is connect up this A being greater than B and AC being less than or equal to BC to somehow then construct an argument that will allow us to conclude that C is less than or equal to 0. Well, it's not immediately obvious to me how we can use A is greater than B and AC is less than or equal to BC to then jump to C is less than or equal to 0. So in my argument, I'm going to use another technique, and it's basically going to break down into a bunch of cases. So I'm going to consider all the possible different values of C. So let's consider case 1. Well, case 1, so they're real numbers right here, so C could be negative, it could be positive, or it could be 0. So the very first case I could consider is, say C is 0. Well, if C is 0, then well, if C is 0, then there's nothing to show, because remember what we're trying to show is that C is less than or equal to 0. So if it's equal to 0, then of course it's less than or equal to 0. So in this case, we don't actually have to do any work, because if C is 0, it's already less than or equal to 0, and that's fine. So let's consider our second case. So in our next case, let's say C is a positive number. So if it's a positive number, then, well, let's go ahead and take my assumption and see if we can connect it up to one of the things that we were given right here. So AC is less than or equal to BC. I'm taking advantage of my assumption right here, and I can divide through by C, and C is a positive number, so I know that this inequality stays the same direction. That means that we are going to get that A is less than or equal to B. Well, A is less than or equal to B? We assumed that A is greater than B. So that means that this case can't actually ever happen. Because if we were in this case right here, then after doing a little bit of work, we would have gotten that A is less than or equal to B. But we know that that's not the case because we started with A being greater than B right here. So this can't be the case because it would contradict something that we were given. So that means that the only remaining case that we have to show is if C is negative. Well, if C is negative, then C is definitely less than or equal to 0, and again, there's nothing to show. So in this case, this argument that I've constructed right here has basically gone case-wise and exhausted all the different cases that C could possibly be. And I have been able to exclude the case that C is greater than 0 because it contradicted one of the things that I was given. And therefore, I'm only left with either case 1 or case 3 right here, where in both of those, there's nothing to show because C is already less than or equal to 0, which allows me to then conclude that C is less than or equal to 0. So this conclusion right here is the end of my proof. This is actually the perfect transition to be able to then talk about proof by contradiction and proof by contrapositive, because this is kind of an annoying kind of proof to have to break it down into a whole bunch of subcases and consider different possible values of C. Maybe C is 0, maybe it's positive, maybe it's negative, stuff like that. So while a direct proof worked in this particular example, we are going to see shortly that there are other proof techniques that will allow us to be able to prove this exact proposition in a much more straightforward fashion.